Welcome to Ask and Learn.
We are finding the volume of the solid obtained by rotating the region bounded by xy equals 1, y equals 0, x equals 1, and x equals 2. We can start off by drawing off the region. The xy equals 1, it's pretty simple. We know that these 2 points are in the curve, 1, 1, and negative 1, negative 1. As x approaches infinity, y approaches 0. As x approaches 0, y approaches positive infinity. And it's the same on the other side. But we don't really care about that because the region doesn't really deal with the negatives. Now, the x equals 1 is just a vertical line right there. X equals 2 is another vertical line right there. X equals negative 1 is a vertical line right there. And the y equals 0 is just the x-axis, so I'm not going to draw that out. What you get is a region with these 4 intersection points. These 4 intersection points are 1, 1, because x, y equals 1. 1, 1 satisfies that, along with x equals 1. It also satisfies that. This point is 2, 1 half, because that satisfies both the xy equals 1 and the x equals 2. Qualification, this is 2, 0, and this is 1, 0. And those are pretty simple. We're rotating about this way, so we get washers. Now when you look closer at this particular region and at its shape, what we get is this shape right here. And we are finding how the radius changes as you change y. And in order to do that, you notice that this region is actually 2 regions. You can call this region 1, call this region 2. Region 1 is pretty interesting, but you'll need integrals to solve it. Region 2 is just a rectangle, but I'll still use integrals to solve it because this is an integration exercise. Nevertheless, we can start with region 2 and find the cross-sectional area. So the bigger area minus the smaller area of the discs. Now, the bigger area is always constant. In particular, is the distance from here to here. And that is the distance from the x equals 2 to the x equals negative 1 line. That is always 3. Now, the distance of the smaller radius is also the same and constant, in region 2 only though. Or in particular, because that's what we're looking at. The distance is from here to here, or the x equals 1 line to the x equals negative 1 line. That is always 2. Now, this is 9, this is 4. We get 9 pi minus 4 pi, that's 5 pi. Now we can look at region 1 and find the cross-sectional area. It's a little more complicated. The formula is still the same. Bigger disk minus smaller disk. But the bigger disk area radius is different. Now, if you look here, this curve is creating the bigger disk. So when you express this curve in terms of the x-coordinates, because that's what we use to find the distances between the vertical lines. This is pretty simple. You divide by both sides by y. You get x equals 1 over y. Now, finding the x-coordinate of this curve gives you the distance of any point on the curve to the y-axis. But that's not what we need. We need any point on the curve to the x equals negative 1 line. So we have to add 1 to whatever the x-coordinate was. So we add 1 to take into account the x equals negative 1 distance to the y-axis. Smaller r, if you look at this region, it's still the same. It's just still 2. Now we can solve. distribute 1 over y squared plus 2 over y plus 1 minus 4 pi. Simplify this, that is pi 1 over y squared plus 2 over y minus 3. And so that is the cross-sectional area for region 1. Now we can do our integrals. Let's start off with region 2 again. Now if you look at this region, we need to find 3 specific points here, here, and here, the y values of those, because that's what we're integrating over. Now if you look at this overall, you'll soon find out that the bottom is just 0, the midway point is 1/2, and the top point is just 1 for the y values. So for this, we're going from 0 to 1/2. And put in the cross-sectional area that we found here and solve. Pull up the pi, 0 to 1/2 of 5 dy. Or really, we can just pull up the 5 itself too and get dy. It's 5 pi of y evaluated at 1/2 and 0. That's just 5 pi over 2 minus 0, just 5 pi over 2. That was a simple integral. Let's do the harder integral. This time it's going from 1/2 to 1 for region 1. Pull out the pi from the very beginning. And if you look at this, we need to plug this in right here. So let's put that in. We need to find the antiderivatives. Antiderivative of this right here. Now that's just another way of expressing y to the -2. So -2 plus 1 is -1. When you divide by -1, you just negate it anyways. So -1 over y plus 2 ln of y, that's an antiderivative of 2 times 1 over y minus 3y. And this is evaluated at 1/2 and 1. Now we need to first plug in when y equals 1. It's going to be pretty long. So let's give ourselves a lot of space. When y equals 1, -1 over 1 is -1. 2 times ln of 1 and minus 3. All of that minus when y equals 1/2. -1 over 1/2 is -2. Just plug in 2 ln 1/2 minus 3/2. So when you evaluate all this and simplify it, we can keep the pi on the outside. Ln of 1 is just 0. So we can get rid of that. -1 minus 3 is -4. We're adding 2 here, subtracting 2 ln of 1/2, and adding right there 3/2. That is -2 minus 2 ln 1/2. We can simplify the ln is 1/2 because there's this rule where ln of a over b is equal to ln of a minus ln of b. So ln of 1/2 is equal to ln of 1. You know what that is? That's just 0 minus ln of 2. So we really just get equals negative ln of 2. So if ln of 1/2 is equal to negative ln of 2, we're adding 2 times the ln of 2 plus 3 over 2. Now let's come up with a common denominator. So put this all under over 2. This now becomes a 4. This now becomes a negative 4. So this becomes equals pi times negative 4 plus 3 is negative 1 plus 4 ln 2 over 2. So that's for region 1. We still have to go back and add this. So let's go 5 pi over 2 plus whatever we find here, which is this, pi times negative 1 plus 4 ln 2 over 2. And what we get is, we pull out the pi, 5 minus 1 plus 4 ln 2 all over 2. And that's just 4. And you could divide by 2. So it all simplifies to pi 2 plus 2 ln of 2. And that's our final answer. If you want to calculate it to the decimal place, this is equal to 10.638. Both of these answers are acceptable.